So here's part one. ln of x is the same as log base e. Get down there. I don't know why I'm in caps lock of x. So the understood base is e, which by the way was Euler's number. I don't know if you remember that or not, but that was Euler's number. State the domain of log base 5 2x minus 1. There's a rule for logarithms. Logarithms puke if you feed them negatives. They just literally hurl it right up because they can't handle it. So I've been writing this. So for the log of anything, the anything has to be bigger than 0 because that's how you maintain positivity. So if I was doing this one, it'd be pretty simple inequality. I'd write 2x minus 1 is bigger than 0. I'd add 1 to both sides. I divide by 2, and I get that x is greater than a half. 3 is a graphing problem. Graph 3 times 4 to the x minus 1 plus 2, and I have to strip it down to 3 times 4 to the x to find the point 0a and 1ab. So if I look at the stripped down version here, which I have written for you, a is 3 and b is 4. So I know I must contain 0, 3, and the second one is going to be 1, and then 3 times 4 is 12. Now I'm going to do my transformations here. That x minus 1 is a transformation. X minus 1 shifts graph 1 unit left, right, which means I add 1 to x. So now because of the shift, I'm 1, 3 and 2, 12. There's this plus 2 at the end. Shifts graph up 2, which means add 2 to y. So what was I before? My little cursor got in the way. I am now 1, 5, and I am now 2, 14. You get to freehand graph this thing. I guess when I give you your test, I'll probably give you a grid. But on this, you freehand graph. And as tall as this thing is, I should probably shift this down here somewhere. Whoop. I just want that line. Okay. Can't get it. There we go. Now I notice this is an exponential. An exponential always has a horizontal asymptote. And I need to make those ticks closer because I have to go up to 14. There we go. I have this plus 2. That is going to shift the graph up 2 units. So the horizontal asymptote is at y equals 2. And I contain 1, 5. About right there. And 2, 14. You'll notice I quit ticking at 14. And then I hit that asymptote and I level out. It's not a hard thing to graph. I don't think it is. But it will be missed. Graph g of x is log base 4 of x minus 2 minus 3. And again, you got the hint, strip it down to log base 4 of x because it has to contain 0, 1, and b1. So I know I have 0, 1, and the base is 4, 4, 1. And just look up here, kids. I'm going to think about my x minus 2. That is a right 2 shift. It's always opposite of whatever's inside parentheses, kids. And there's that minus 3 at the end, which is a down 3. So to go right 2, I'm going to add 2 to that guy and 2 to that guy. I'm going to become 2, 1, and I'm going to become 6, 1. Down 3 is going to take away from your y values. So 2, negative 2, and then 6. Something seems wrong here. It's that. It's a typo. I hate that. I do have a bit of dyslexia. So that's a 1, 0. Right 2 makes that 3, 0. I either have dyslexia or exhaustion, one or two. Anyways, right 2 is now corrected. Down 3, I'm going to become 3, negative 3. And I'm going to become 3, negative 2. And the reason I noticed this is because these points were on the same y value. It was going to be a straight line. Not that you care. But again, typo there, and I trusted it. Oops. I'm good with this. Logarithms do have a vertical asymptote. There was a right 2. I'm going to draw that in. Your VA is at x equals 2. We will never cross it. We end up containing the point 3, negative 3 and 3, negative 2. And logarithms look like R's. That's what they look like. So I'm going to draw me an R. And I'm going to make sure I don't cross that line. All right, rewrite log base 7 of 12 using any form of change of base that you like. The first one would be obviously log A over log B. Remember, log is Bay. In this case, log is Ba. So this would be log 12 over log 7. The other one you can do is you can do ln of A over ln of B. So this would be ln of 12 over ln of 7. Or, here's what you can do. You can do log base C of A over log base C of B. And it'd be really cool if you made up your own base. I am going to let C equal how y'all feel the I don't care face. So this will become log based I don't care of 12 over log of I don't care 7. I have no idea if that's the I don't care face or not, but it basically means you have no emotion. Anyways, there you go. That's one way of doing it. Find the inverse of f of x equals 2 times 3 to the x minus 1. And the first deal is we swap x and y. We beat that to death. We literally get the f out here. Step 2 is to resolve for y. And we're going to do that by, in this case, this is a convert to log. Before I convert to log, I have to isolate the base. I divide both sides by 2. X over 2 equals 3 to the y minus 1. And I can go through and I can identify my parts. My base is 3. My exponent is y minus 1. And my answer is x over 2. And again, log is Bay. So I have a base of 3, log base 3. My argument is now x over 2, and I equal y minus 1. I'm still technically on step 2, so I'm going to add this 1 to the other side. Log base 3 of x over 2 plus 1 is y, and step 3 is notation. So log base 3 of x over 2, add 1 is, and this was f, the inverse of f of x. Easy peasy. I think it is, but what do I know? All right, 7 is just a pure blown, easy as it gets conceptual question. That was not what I wanted. Let me save this. Oh, I can't save that now anyways. I must have hit the wrong key. All right. All functions and their inverses have y equals x as their line of symmetry. This makes sense to me. If I read left to right, it says y becomes x. If I read right to left, it says x becomes y. And I know that inverses swap x and y. That's what they do. But anyways, the answer to this thing is that y equals x. Find the inverse of this logarithm. And again, our 3 steps were pretty simple. It was swap x and y, resolve for y, and notation. So f of x, which is y, and by the way, f of x is y. Y right here becomes x. The x becomes a y. And there's a plus 1. What I'm going to have to do here first is I'm going to have to isolate the log. So I'm going to take 1 away from both sides. I can type. And now what I'm going to do is I'm going to identify the pieces. I have a base of 3. I have an argument of 5y, which means my exponent has to be x minus 1. I'm going to rewrite as an exponential. So my base is 3. She is roof-topped to the x minus 1. And that would have to equal 5y. I'm not done solving for y. I'm still on resolve for y. So I'm going to divide that 5 out. I'll have to write that. I would have, I'm just going to put it over a 5. Okay? And now I'm at notation. 3 to the x minus 1, sitting pretty over 5, is, that was called f of x again, the inverse of f of x. 9 is a converting. It says convert the following logarithmic equation into an exponential and do not solve it. Log of x has an understood base of 10. So I'm going to put a little 10 there. My base is 10. Remember, it goes log is bay. My answer is 3x minus 1. And my exponent is going to be 5. So when I convert this, I'm going to have 10 to the 5th equals 3x minus 1. It says do not solve. That's where I stop. I'm just seeing if you can do conversion. 10 is convert the following exponential function equation into a logarithm, but do not solve her. And before you do that, that's the deal. Before you can convert, you must isolate. You have to isolate. So I notice I can take away 5. I'd have 3e to the 4x minus 2. And if I take away 5 from 14, I get 9. Then I can divide out the 3. I'd have e roof-topped to the 4x minus 2 equal to 3. And then I go through and identify my pieces. I know my base is e, my exponent is 4x minus 2, and my answer is 3. And again, log is bay. So I happen to be in possession of a log whose base is e, whose argument, according to what I saw, is 3, and it equals 4x minus 2. Now don't stop. Log base e is ln. I will take off a little bit. It needs to be written as a natural log, because if it doesn't, you don't understand the understood. And then we have the easy questions on this page. These. Does y equals 2 times 3 to the x minus 1 plus 4 represent growth or decay? And what you have to do is you have to look at the base. If the base is greater than 1, it is growth. And here, the base is 3. So I'm not going to worry about anything that says decay. Now that's how hard it is to pick out growth or decay. Now it says growth, the 3, growth, the 2. The base was 3. It's got to be choice B. And the rest of it's right. It tells us the function is tripling as x increments. So if x grows by 1, the function triples. That's how it works. Does y equals 2/5 x represent exponential growth or decay, and why? So here the idea is if the base, at least if the absolute value of the base is less than 1, it is decay. And number 12's base is 2/5, which is less than 1. And if you don't know 2/5 is less than 1, we have issues. And from there, it's more or less just picking out the right stuff on this. I made these multiple choice. But anyways, it's decay, so forget growth. And this one talks about whoops, that's the right one. See, it says 2/5. Got to be choice A. That one talks about a 3. No, it's in the wrong spot. And that is the end of part 1. So there you go. I hope that helped.